So let's say, yeah, so in the previous class, we saw that how do we get this EMF, which is varying with time from AC generator. How do we get that? So let's say we have this magnetic field, right? This magnetic field which is constant. And from EMI, electromagnetic induction, we already know that from Faraday's law, know that we can generate the EMF, right, by changing the magnetic flux, right? So this is what we got from, so that is what we have learned in the previous chapter, right? So from Faraday's. And we also know that what is this magnetic flux. So taking the analogy from, and this minus part, yes, this minus part comes from the lens, right? So we know that this taking the analogy from the electric charges and fields. So if you guys remember that what was this electric flux? What was this electric flux? Whatever the flux is that is related with the AC, right? So when I say electric flux, then electric field lines passing normally to the surface. Similarly, we talked about this magnetic flux in the EMI part, and then we got that this was d by dt. Magnetic flux was B dot A, so that would be B A cos of theta, right? So this was the magnetic flux that we got. And now we want to, if we want to change the magnetic flux, so then we can change this magnetic flux in three ways, right? Either we can change, so we can get this EMF by changing magnetic field, by changing area, by changing this theta angle, right? The angle between the magnetic field and the area vector, right? So we know that in the AC generator, what do we do? In AC generator, we have this aperture, right? We have this aperture which we put in this plane, right? And then we apply some magnetic field. So this aperture is kept at this angle, right? So magnetic field line, they are passing through it, right? So what kind of magnetic field is this? Is this a constant one or is this a, this is some permanent magnet, right? So what kind of magnetic field we are getting? The constant one or the varying one? What is
Constant.
constant one we are getting, right? So we have this magnetic field. This is constant. Okay, so then this cannot create EMF. Now what we are doing is that we have this area of this aperture, right? We have this aperture. So we are, so is that this is not shrinking or this is not expanding, right? So then area is what changing or constant? This is also constant, right? Because the aperture is not changing. We are not changing the shape of this aperture. Now what we are doing? we are rotating this aperture by some means of this meter. So we are rotating this, right? So if we rotate this thing, let's say this is the axis of rotation, right? This is the axis of rotation, and then we are rotating this thing by some constant angular velocity omega. Right? So we are rotating this thing. So then, what is changing? What is changing? Magnetic field is this. Area vector, if this is the aperture, so area vector would be normal to this, right? So let's say that we have these uh, so let's say we have these magnetic fields, right? So this is north pole, this is south pole. Magnetic field lines are passing like this. And what I do is that I put this aperture like this. So magnetic field is passing like this, right? And I have this angle. So what is the angle between the magnetic field and this aperture? What is the angle? Yes,
90
magnetic.
degrees.
Yeah. So this is perpendicular, and this is going like this. So we have this is magnetic field going this way, area vector going this way. So we have 90 degrees. So flux would be how much? Flux is how much? PA cos theta, remember? PA cos theta, so your theta is 90. Your theta is 90 degrees. So flux at this position, this is PA cos of 90, so this is 0. Right, so your magnetic flux is 0. Now what you do? You have this aperture, then you rotate this aperture in this way. Right, so you have this aperture, then you rotate this aperture in this way. So now what is the angle between the magnetic field and the area vector? What is the angle? This is the direction of this is the direction of the area vector, and your magnetic field was in this direction. Both have same angle, right? Both have same angle, so angle is 0 degree. So you have increased, if you rotate it by 90 degree, then you have increased this thing. You have increased your flux, BA and cos 0. So this has become how much? This is BA. So this has become maximum, right? Your flux was 0, and then you increase this flux, so it has become BA. So what is happening to the flux? What is happening to the flux, guys? Yes, what is happening to the flux? So it is changing, right? First it was 0, and then it has become maximum. So you are changing the flux by means of changing theta, right? And let's say theta is the angular distance, right? Theta is angular distance, and t is your time. So what is the angular velocity? Angular velocity is theta by t. So you can write your theta as omega t, right? Is it clear? Because this is the omega with which you are rotating this aperture. So you are rotating this aperture, and then you are getting a change in magnetic flux. So you are changing the magnetic field. Subsequently, you can change your flux, so you can get your EM. So that is the whole idea of this AC generator, right? That is the whole idea of AC generator. So from AC generator, what do you get? from AC generator, what do you get? You get your EMF, which is minus d by dt of VA cos theta is omega t, right? And we know that this magnetic field is constant. This is a constant, and this is changing with time. So this is variable. So VA, we can take it outside, and cos omega t is how much? So minus d by dt of cos omega t. So what we will get? This would be minus VA sine of omega t and minus. And then what would be the other quantity that we will have? What would be the other quantity? Yes. What is the other quantity that we have? If we
Sir,
differentiate,
can you repeat? Can you repeat again?
yeah, so I'm saying that I'm taking the differentiation of this quantity, right? So I'm taking the differentiation. So let's say this is theta, right? So we know that d by dx of cos x, that is minus sine x, right? That is the differentiation. But this is with respect to t, and this is omega t. So omega is multiplied with t, right? So then we have to use the chain rule, which means that we have to take the differentiation of this thing omega t, right? So then omega is again constant, so we can dA and sine omega t, and this that is 1. So then we will get BA omega sine omega t. So that is the whole idea of that is the whole idea of this EMF generated by AC generator, right? So we will get a varying function of EMF. In the case of EMF of cell, we get the EMF as simply higher minus V lower. This was some right. So this was a constant quantity. But from this AC generator, we are getting a fluctuating voltage. So if we write sine omega t, so this thing, this is the sinusoidal, right? So this EMF is sinusoidal. So what is the variation that you are getting? This E naught is the maximum EMF. You can also call this. So if we Okay, yes, sorry guys, I got disconnected. Yeah. Okay, so what would be the variation of this EMF at theta equal to 0, right? At theta equal to 0, sine 0 is 0, so this will be 0. And if I go to, let's say, pi by 2, right? And if I go to, let's say, pi, and then 3 pi by 2, and then 2 pi. So the variation would be, what would be the variation? At 0, this is 0. At 90, it will go, sine 90 is 1. So sine 90 is 1, so this would be E naught. So this would be max. So it will increase. And then again, if you go higher than that value, so it will decrease. And at 270, this would be minus of this thing. This would be this, and then it will increase again. So this is the behavior of the. And there are three kinds of EMF that we write. Is my voice getting disconnected? Is my voice breaking, guys? Yeah, is my voice breaking?
Right now it is okay, sir, but in between it was breaking.
Oh, yeah. My internet
Sir,
is.
at last, can you show? I'll just take a screenshot of everything.
Yeah. So I will give the time to note it down, right?
Okay, sir.
So I will give you
Yeah, okay,
guys.
sir.
Yeah. So this is the EMF that we get from AC generator, and there are three main parameters that we associate with this EMF. So one is the average EMF in full cycle. Then we write average EMF in half cycle, and then we write mean square EMF, right? So there are actually four parameters. One is your max, right? That is your E naught. Then you have E average. This is represented by T. And in full cycle, this is we are going to calculate. And then we have E average in half cycle. This we are going to calculate. And fourth one is this is E RMS. Right, root mean square. So if we write it in the reverse order, right? If we write it in the reverse order, so we are writing mean square EMF, right? So root mean square EMF. So first we have EMF, and then what we do? We square it, and then we take the mean. So mean is this thing, and then we take the root. So this is what we call the root mean square, right? This is also we are going to find out. So these are the four parameters associated with the EMF generated from the AC circuit or the AC generator. So you guys please note down this part. Okay, and then yeah, I have to reach this LCR circuit. So I will quickly write those results, right? I will quickly write those results. But before we do that, yeah, you guys please note down these terms. Whenever you guys want me to scroll down, please tell. So the numericals will not take that much of time. So this will next class chapter, right? But before we build the background, so in today's class we'll build the background, right? Yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys have noted it down, please so that I can scroll down the screen.
None, sir.
Then Yeah, whenever you have noted guys, that yes, done guys. Okay, if he has uh, then quickly note down the part. Okay, you have to cover a lot of things, right? Yes, noted, guys. Done.
Yes, sir. Done.
Okay. Then we have to find out this thing. First parameter, that is the maximum voltage that we have found, right? E naught. This is very crucial. And then we have to find out the other three, which is the average. How do you calculate the average of a function? So calculate average of a function in a period of time t. That is given by what? That is, let's say if I want to find out the average of this. So this would be 0 to t, and ft dt divided by total time. So that is the average that I define, right? So that is the way I calculate the average. So let's say I want to calculate. So first is that I want to calculate the average of E in total time t. So that would be how much? That would be 0 to t, and E and dt divided by t. So this would be, and I will directly write, so this would be 0 to t E naught sine omega t, and dt divided by, let me write it as 1 by t. This is 1 by t, 0 to t. E naught is taken outside. So this is integration of sine omega t dt. So if I integrate this thing, so that would be E naught by t, integration of sine omega t. That would be how much, guys? Can you tell me? What is the integration of sine omega t? That would be how much, guys? Yes. What is the integration of sine omega t? This part you guys have already done. Right? What is the integration? Yes. What is the integration, guys? Cos omega t, yes. By omega only, not omega t. So yes, I should correct. Cos omega t, but that would be minus cos omega t divided by omega. So this is the integration, right? So this would be minus of cos omega t divided by omega, and from t to 0. So if we write this thing, if I take minus omega outside, so this is E naught omega t, and this is cos omega t. Upper limit is t, lower limit 0. So first I have to put the upper limit, so that would be cos omega t minus this is cos 0, right? So how much is omega t? If we remember what is omega t, so if you look at this thing, right? So the time that it takes for this EMF to complete a full cycle, that is called the total time period T, right? This is the total time period, and we know that the angular distance that it has covered. So in full cycle, the angular distance is pi, right? Theta is pi. Time is this t. So what would be the angular velocity, guys? What would be the angular velocity? That would be theta by t, right? So this for full cycle, this is the angular velocity. So omega is 2 pi by t. So if we recall this thing, and if we put the value of t, that would be 2 pi by omega. So if we write this thing in here, right? So this would be minus E naught omega t, and cos omega t is 2 pi by omega, and minus cos 0 is 1. So can you guys tell me what is the value of cos 2 pi? What is the value of cos 2 pi, guys? What is the value? Cos 2 pi, if you remember the variation of cos, so cos goes from, let's say 0, this is 90, this is pi, this is 370, and then you have this 2 pi. So cos 0 is 1, then it at 90 it is 0, then at pi it becomes minus 1, right? This is 1, this is minus. So at 0 it is 1, then at 90 it is 0. At 180 this is minus 1, and at 370 it is again 0, and at 2 pi it is, what is the value at 2 pi?
1.
1. So this is the value, right? So this is 1. So 1 minus 1, that is 0. So we'll get 0. So average EMF at full cycle, you get 0. That is the one thing. And I will also write the average in half cycle, and I will also write the average in ERMS. I will also calculate. I will calculate all these things, and then you guys calculate terms. Average in half cycle. So that would be how much? That would be 0 to half cycle, and E naught sine omega t dt divided by t by 2. So this t will come in the numerator, and then we have this integration, and all the things are similar, so we will directly write by t. So this would be t naught by t integration of 0 to t by 2 sine omega t dt. So this is how much? T naught by t integration is minus cos omega t, and limit is t by 2. So minus is outside by t, and then omega is also outside, and then cos omega t, t by 2 is 0. So if we put value to be cos omega and t by 2, and minus cos 0. So this would be how much? Omega t, you guys already know. What was omega t? What was omega t? Remember, omega was full distance divided by the time. So omega t is 2 pi, right? Omega t is 2 pi by 2. So this cancels, minus cos 0. So what is the value of cos pi? If you guys remember, please tell me what is the value of cos pi. How much is cos pi?
-1.
Minus, right? So minus 1, minus 1. So this is minus 2 E naught minus 2. Omega t is 2 pi, right? So minus minus plus cancel, and you will get 2 E naught by 5. So this is your average EMF in half cycle. The average EMF in half cycle. And then the third one is ERMS. So what is the meaning of ERMS? You calculate E, you square it, you take the average, you So that is ERMS. So first we have to find out E square, right? E square would be how much? That would be E naught sine omega t whole square. So that is E naught square sine square omega t. Now we have to take the average of this thing. So average of E square, that would be how much? That would be 0 to t and E square dt divided by t. So this is the average of this thing, E square. And we know that this, so let me write it as 1 by t. And this is E naught square sine square omega t. So now we have to take the integration of sine square. So how do we integrate this? So we will use the trigonometric identity, right? We'll use a trigonometric relation that relates sine square with something, right? So we know that what we have to recall, that cos of theta, that is 1 minus sine square theta. So we can find out the value of sine square, right? Remember, for sine this is theta, for cos that would be 2 theta. So if I find out the value of sine square theta, that would be how much? This will go other side, I take minus, so 1 minus cos 2 theta divided by 2. So if I write sine square omega t, that would be how much? 1 minus cos omega t divided by 2. So this is how I get sine square omega t. And I will put this value in here because I cannot take the integration of sine square, right? So now by putting this value in there, what we will have E square average, that would be 1 by t E naught square 0 t and 1 minus cos omega t divided by 2 and dt. So how can we integrate this thing? So there are two terms, right? So we will write them separately. So if we write them separately, so one is 0 to t 1 by 2 dt. This is one. The other is cos omega t by 2 dt. Remember, this 2 omega t is angle, so do not cancel this thing with this one, right? These are angles. So we have this constant quantity. So if we integrate this thing, so we'll get what? We'll get 1 by 2. And integration is t from limit t to 0. And this cos 2 omega t integration would be how much? 1 by 2 is taken outside. Integration of cos 2 omega t is plus sine 2 omega t divided by 2 omega, right? And then we put the limit t to 0. So then what we will get? We will get E naught square by t. This is half t minus 0. This is half 2 omega 4 omega outside. So then this is sine of t omega t minus sine of 0. Right. So this is E naught square by t. this is t by 2 minus 1 by 4 omega. And cos 2 omega t, we know that that is this is sine omega t is 2 pi, so that is 4 pi minus sine 0. So can you guys tell me how much is sine 4 pi? How much is sine 4 pi? Yes, if you remember the variation of sine function, right? If you remember the variation of sine function, what would be sine of 4 pi? So this will again go down, and this will be variation. This is yes.
Yeah.
What? Yeah. What are you saying, Aisha?
Is it 0?
0, right? Yes. So 2 pi in the other cycle we will reach 4 pi, right? So this would be 0 again, right? So yes, absolutely correct. So that would be 0. So this is 0. Sine 0 is 0. So one part is 0, and we will get what? Oh, this is right. So then we'll get only E naught square by t by 2. This will cancel, and we will get what? E naught square by 2. So average of E square, right? This is it. Now RMS is how much? RMS is square, mean, and so this thing we have found out, and we have to take the root of this thing. So this is naught square by 2. So we will get E naught by root. So this is the RMS value that we get. Right. This is very crucial that in every circuit, they give you the RMS values only. You don't get peak values, right? So let's say that in your household supply, the value that they are telling you is this RMS value, right? This voltage 220 volt. So this is the RMS value. Okay. So always remember that this RMS in every AC supply, we mainly talk about this RMS value. And this RMS value is related with this peak value, right? So this is the relation that not by. So we have four things, right? One is peak value, right? The other is average in full time, that is 0. The third is average in half time, that is 2 E naught by omega. What is that? Yeah, 2 E naught by pi. E naught by pi. And then the last one is RMS, which is E naught by 2. So please note these things down, and then, yeah, you understand about the other circuits. Okay, please note it down. If you guys have any doubts, please tell me. Yeah. So the next part that we will do is different circuits and yeah, then we will do the questions. Whenever you guys want me to scroll down, please.
Done.
Yeah. Okay, then please. Yeah, whenever you guys have noted, please.
Done.
Done. Aisha.
Done.
Then yeah, please. Yes, noted, guys.
Done.
Done. Then please. Yeah, whenever you guys have. Yes, done, guys. Yeah, then and whenever you guys have completed, please tell me. So then we have the phasor diagram, and then what I will do is that I will directly write the LCR circuit because you guys have already studied this different so resistive circuit, capacitive circuit, inductive circuit. All these three things we have done separately, right? What we will do is that we will study about all of them together. Yes, whenever you guys have noted that. Okay, done. Yeah, everybody noted. Okay, so if all of you guys have noted, so then let us understand, right? Let's say we were talking about all these previous sections. We were talking about the EMF, right? We were talking about the voltage. And let's say if we have this supply voltage, right? If we have this supply voltage and this is represented by this thing. If we have this supply voltage and we connect different circuits to it, right? If we connect different circuits to it, so I will directly write the result, right? And if we connect, let's say, inductive circuit, and then if we connect capacitive circuit, right? So for the resistive circuit, if our, let's say, V is V naught sine omega t, this is, I'm writing it as E. So E is E naught sine omega t. So I'm just writing it in the terms of V, right? So V is V naught sine omega t that I'm getting from AC generator. Right? This is from AC generator I'm getting, and from this supply I'm connecting a resistor. So I know that my current in resistor is simply I. This is I, and this voltage is simply IR. So for this case, I get my current as yeah. So for this case, I get my current as I naught sine omega t, right? So this is what I get. And so we see that if I write this voltage and if I write the current in terms of this. So in subsequent circuits, we will talk about what would be the implication of current from this volt supplied voltage. So if we are supplying some voltage, then what kind of current we will get in different circuits. So in this circuit, what would be the current? In this circuit, what would be the current? So for the case, let's say the current is I naught sine omega t plus phi. So this is the current I'm getting in different circuits, right? So in the case of resistor, right, here this phi is called the phase difference. So phi is phase difference, and you guys have studied this in your CBSE class that for the case of let's say for the case of resistor, phi is 0, right? For the case of inductor, the current is lagging by pi by 2. For the case of capacitor, the current is leading by pi by 2. So in here, this is lagging with voltage. This is same phase, and this is ahead leading. This part you guys have already done, right? Do you guys want me to show these things again, or is this okay with you guys? How to get these things? Do you guys want me to show those things, or
No, sir.
is it okay, right? So
Yes, it's okay.
yeah, so just remember these things, right? So these things we have already done in the CBC. So for this case, you will get so in here you will get your current as I naught sine omega t and minus pi by 2. And in here you will get your current as I naught sine omega t plus pi by 2. These are the two things that you will get, right? So if we write the phasor, so from the phasor perspective, if we write the phasor diagram, or before we write these things, so for the case of resistor, the resistance is R, right? For the case of inductor, you have the resistance which is whose role is played by inductive reactance, and that is represented by XL, which is omega L, where your L is inductance. And then for the case of capacitor, right? For the case of capacitor, you have capacitive reactance. This is what? This is XC, which is 1 by omega c, where this C is your capacitance. Right? So these are the crucial things that we have to remember. Right? And this omega is the frequency that you guys are providing. Right? So this omega is the supply voltage that you are applying. So this is the frequency of the supplied voltage. So from these things, right? And if we recall the phasor diagram, called phasor diagram. So phasor diagram are the rotating vectors, right? And let's say this is your V naught, right? This is your V naught, and this angle is omega t. So this would be the, if you drop this thing on y-axis, so you will get your instantaneous EMF, right? Similarly, for the case of different currents, we get different kinds of phasor diagram, right? So if we write the phasor diagram of LCR circuit, this is very important. So we know that, what do we know? Supply voltage. We have to assume this thing that supply voltage is V naught sine omega t, right? So the voltage is making this angle, and your current is I naught sine omega t plus phi, right? So keeping these things in mind, let's say if we draw our I naught, right? So if I draw this I naught, right? This angle is how much? That is omega t plus phi, right? This is my I naught. And if I drop this thing down, so I will get omega t plus phi. Now, uh, this is the current that I have. So, what would be the voltage in LCR circuit that would be with the same phase as the resistance? What would be the voltage that would be in the same phase? Yes, what would be the voltage that would be with the same phase? Yes, guys, what would be the voltage? So resistance is same thing. So VR would be there. This is, let me write it as VR. And I'm writing this peak voltage. VR is the peak voltage in resistive circuit, right? So this is VR. What is lagging and what is leading? Right. What is in what circuit? So you see that in inductive circuit, current is lagging, right? Inductive circuit current is lagging by pi by 2, which means that voltage is ahead of current, right? So which means that voltage is ahead of current by 90 degrees. So voltage in inductive circuit. VL, that is ahead by 90 degrees. And then similarly, the capacitive circuit, right? So voltage in capacitive circuit, that is lagging behind, right? So this would be this that. This is right. And if we write the resultant of these vectors, so resultant V, that would be how much? That would be R, E, and Vn. So that is the result, right? And if we write this thing, so this is VL and this is VC. This one is greater. So this part would be how much? From here to here, from here to here, that part would be VC minus VL, right? This is VC minus VL. And this is your VR. So if we take the parallelogram law, right? If we make a parallelogram, so this would be your resultant. This is your V naught, right? This is your V naught, which is making an angle omega t. Right. So how do we calculate this V naught? So V naught would be how much? V naught would be top. This is how much? VR square plus VC minus V naught would be VR square minus VC minus VL, right? Using the parallelograms law. This is the result that we get, right? And this is in terms of peak voltage. Okay. In terms of RMS, this is how much? This is VR RMS square plus VC RMS square minus VL RMS and whole square. So in terms of RMS. Okay, so I will continue from here in the next class. In the next class, we'll do only the numericals, right? Because these are the things that we need. So you guys, please note down from here. Quickly note it down, and then yeah, in the next class we'll only do the numericals, right? You guys have to remember these things. Yes, quickly you guys note it down, and then yeah.
Done.
Yeah. Then Yeah, then please. So in AC chapter, we have always remember that you have a supply voltage and then you are getting some current. So what is the relation between voltage and current? And then you obviously you calculate power, AC supply, all those things. But you need to remember those currents and voltage. And remember, those are not algebraic sum, right? Because all those voltages are at different phase. So that is why we cannot add them in simple algebra, right? So let's say that you are given an LCR circuit, right? L, C, and R circuit you are given, and then you are given a supply voltage. Let's say this is 50 volt, this is 20 volt, this is 30 volts. So total voltage will not be 5 to 7000. This would be totally wrong, right? Because they are at totally different phase. In the normal circuit, what do you do? So if you have this voltage and this voltage and this voltage, let's say this is 3 volt, 4 volt, 5 volt. So then you just simply add them, right? 2, 3, 7, 5, 12. So you just add them together. But in this case, they doesn't. So they do not add algebraic. This is the thing that you have to keep. Okay, so please note down this part and then we'll stop and in the next class we'll do more. You guys please come prepared with this conceptual questions. Yes, noted everyone. Got disconnected in the middle. Rachita got. Noted guys.
Done.
Yeah. Okay, so